Today, ladies and gentlemen, we're going to talk about a new topic. We're going to talk about something called transformations. Now, transformations are used a lot, say, in the animation industry. What you do is you take an image, for example, like this trapezoid I've got, and what you do is you manipulate it. In other words, you can move it around different ways. And in animation, there's lots of different ways that we can move a particular image across the screen. For example, let's say I started here and I wanted to move it simply to the right and up, right? This happens a lot of times if a character, say, is walking along or and then moves up to another part of the where you can see your view screen. And we call that particular maneuver a translation, right? Sometimes it's referred to as a slide, because what I could do is I could take this piece of paper and just slide it to its new position, all right? Now, with transformations, there's a couple of things we need to keep in mind, all right? First, it's about the coordinate plane in general. The coordinate plane has 1, 2, 3, 4 sections, and that's how they're numbered. So 1, 2, 3, and 4. We use Roman numerals. We call them quadrants. So for example, if this was my original trapezoid, so it was here in quadrants 3 and 2, and I moved it, say, up and to the right, now it's sitting in quadrant 1. So we need to know that. Also, we have an axis, all right? So this is the x-axis, and it runs side to side. And then we've got the y-axis. It runs top to bottom. And what it does is it is numbered off both on the x and the y, and it lets us know locations, all right? So for example, let's go with this point right here on this trapezoid. We'll call it point A for now, just to give it a name. This is what we call the pre-image, right? This is where our trapezoid started. So A currently is at the point 4, -4 there, -3. So we went from the origin, that's what we call this location where the two axes cross. We go left 4 and down 3, and that's where A is currently. So this is called the pre-image, all right? This is where it ended up. So what we call this, let me bubble it in, we call it A prime. That's like a little apostrophe or a 1, and that lets me know where the point ends up, right? So this is what we call prime notation. So this is the pre-image, this is the final image. We read this as point A, and this is point A prime. And we can see that it moved from the point -4, -3, to the point 2, 0. Notice from the origin, I would just simply go 2 over, and I wouldn't go up or down any. A is sitting right there. So this is what we're going to be doing today. We're going to be talking about situations like this, where we take our original pre-image and we move it to its new image location. All right, so let's take a look at it. First thing I want to try and do with you, and again, the notes are online. If you have the ability to print, go ahead and print those off. If you don't have a printer, then these will be available at school. You can go pick them up at your convenience. But again, you'll definitely want to have the notes. That way you can follow along, write things in. It's just going to make your life easier. So let's take a look. First thing we're going to do is describe what we're seeing in words. And then we're going to describe it using something called coordinate notation. And that sounds really, really complicated. And I promise you it's not. It's pretty easy. So let's start off by dealing in words. So notice I've got a triangle. I've got X, Y, W, all right? And then I see my new coordinates, X prime, Y prime, and W prime here in blue. So what I need to figure out is, how did this image move? How did we take this black triangle and maneuver it into its new position? Well, I'm going to pick just one point and try to follow it around, kind of like what we did here. All right, we picked point A and moved it around. Well, I'm going to pick just one of these points and see, well, where is it moving to? So let's take a look. X is currently right here, and X prime's up here. So how could I move? Well, one way I could do it is move 2 boxes to the right. So I'm going to write that down. 2 units right. And let's see where else I need to move. Well, notice just moving it to the right isn't enough. We're not lined up. So now I need to go up. So I'm going to go up 1, 2, 3, 4, 5. And that's 5 units up. All right. So that's describing it in words. All right. Let's talk about coordinate notation. Coordinate notation is an algebraic way of describing exactly what we did in English. So here's how it looks. It always starts, I'm going to write it down here. It always starts with X, and y. All right, what that x and y represents is this original coordinate. And notice we're going to use variables because I don't know where that point's ever going to be. I could use it to describe x's location or y's location or w. Those x's and y's just mean I know the location of x, but I'm not going to get too specific because x is in one spot, y is in a different spot, and I want to be able to use this idea wherever I want. All right, so we're going to start there. The arrow that I'm drawing represents a transformation. I'm going to change this somehow. All right. And here's how I'm going to change it. I'm going to take my x coordinate, right, my side-to-side coordinate, and I said I would go 2 units to the right. Well, in math, if we go 2 units to the right on our coordinate grid, that means that I added 2 on. All right. If I wanted to go left, then I would have subtracted 2. And I'll show you why that is in a minute. Next, I'm going to describe what happened to the y. Well, on y, notice y runs up and down. This case, I went 5 up. So I'm going to write y add 5. All right. If I wanted to go down, I would have subtracted 5. And let me show you why this works. Y is currently at the coordinate 1, -1. All right. That's where it was. That's the pre-image. Let's see where it ends up. All right. If I add 2 to the x, so 1 plus 2 is 3. And notice x prime is 1, 2, 3 boxes over. So far it seems to be working. Let's try this. We said to y we would add 5. Well, let's do that. Well, -1 add 5 is 4. So let's write that down. Well, if I go over 3 and up 4, sure enough, I've ended up right on x prime. So what this allows me to do, coordinate notation, it allows me to take points and move them algebraically, whereas word form, it makes me sit there and count everything out. So they both get the same outcome. One's just a little bit more efficient than the other. All right, so let's try another one. Let's look at this one. In black, we've got our original. In blue, we've got the new, our final image. So let's pick a point to maneuver around, because trying to look at all of these gets a little cumbersome. Let's look at Q. Q's kind of off here by itself. So to go from Q to Q prime, it looks like I'm going to have to go to the left. Let's count. 1, 2, 3. So let's write that down. I'm going to go 3 units left. And now let's see how far up I've got to go. So in this case, I'll go up 1, 2, 3, and 3 units up. All right. Well, let's try our coordinate notation now, and let's see what that looks like. So our coordinate notation, remember, always starts with x's and y's. We don't want to go off screen there. X's and y's, because we don't know where our original coordinate is. It could be different depending on what we're doing. So it's always just going to be x, y to describe this location. All right. And let's see what happens. So we said we would go 3 to the left. Well, remember, we said if you went right, that is 2 added on. If I go left, that's going to be a subtraction issue. So x subtract 3, because I went 3 to the left. And then I'm going to go up. Well, we said that's a y issue. And just like before, we went up 5, so we added 5. Well, if I go up 3, I'm going to add 3. And again, we can look at those coordinates and see how that works. This Q is at -1, -4. If I take 3 more away, that puts me at -4. And sure enough, 1, 2, 3, 4 over. That works. -4, right, is the y. If I add 3 on, that puts me to -1. So I went over and then just down 1. So it looks like the coordinate is in the correct position. So that coordinate notation looks good. Right? I'm not going to count like that anymore. We're just going to write these out because hopefully you're seeing how this works. It's not too bad. So let's look at number 3. In words, again, going from black to blue, I'm going to look at point U just because it's out there by itself. Looks like I'm going to go to the right 1, 2 spots. So 1, 2. So 2 units right. And it looks like 1, 2 units down. So there it is in words. Let's write it in coordinate notation. So the coordinate notation for this, remember, always starts off with x's and y's. So x and y to represent the original pre-image. Now let's draw what the image looks like. If I went 2 to the right, that's x add 2. And if I went down, that's y subtract 2. So remember, right is positive, down is a negative issue. All right, let's do this last one. This one, let's look at point W. All right, so it looks like I'm going to go right 1. So let's see, 1 unit right, and then it looks like 1 unit down. Right? Let's write out our coordinate notation for that. If we're going to go 1 unit to the right, there we go. So our original pre-image now to the new image. If we go 1 unit right, that's an addition issue. So x add 1. And then if we're going to go 1 unit down, that's going to be y subtract 1. So that's some of the things that you'll be doing today, is describing these transformations. In this case, translations. How did we move this black pre-image onto the blue image? All right, image being the final location. And remember, we're talking about x's, right? That's the original, and then x prime is how we would read that. So make sure you know the notation. All right, well, let's actually try one. Let's actually do one ourselves. Instead of describing it, let's actually get it done. So in this case, our translation in words is to go 4 units left and 6 units down. Okay, we can do that. So let me grab my pen. And we're going to pick 1 point to start. Always start with just 1, and then we can add the others in. So I'm going to start with S, just because it's up here on its own here. So I'm going to go 4 units to the left. So 1, 2, 3, 4. I counted 4 boxes. 4 whole boxes. So I can't start here and say 1 because I haven't been anywhere yet. This is 1. This is 2. This is 3. This is 4. 4 to the left and then 6 down. 1, 2, 3, 4, 5, 6. So I'm going to make my point and call that S prime. Right? Then we basically do the same thing over and over and over again. So we've got R, we'll go 4, 1, 2, 3, 4, and then down 6, 1, 2, 3, 4, 5, 6. So there's R prime. For T, we'll go 4 to the left. So 1, 2, 3, 4, and then 6 down. 1, 2, 3, 4, 5, 6. There's T prime. And then for U, the same thing. 4 to the left. 1, 2, 3, 4, and then 6 down. 1, 2, 3, 4, 5, 6. Now I want you to notice something. There's U prime. Once I get it drawn, that is. And if it helps for you to grab a ruler, go ahead and do that, or a piece of paper, you can fold it in half and use it as a straight edge. Notice our original pre-image and our final image are the same, right? We call that congruent, right? That's the mathematical term. It means that these two are identical, same size, same shape, every way. If you're doing these translations today and you get something that is not congruent, then you've done something wrong. All right. Every pre-image and image should be exactly the same size and shape. Now, obviously not the same location, but the same size and the same shape. All right. Let's try another one. This one's kind of smallish, and that's okay. We're going to go 6 units to the left and 2 units down. So I'm going to start with B. So 6 to the left. Let's count it off. 1, 2, 3, 4, 5, 6. And then 2 units down. 1, 2. There is B prime. Make certain you're labeling your points. We want to know what the original image and the final, or excuse me, original pre-image and the final image end up and what they look like. So make sure you label them. If you don't label them, it's going to get marked wrong. All right, let's try it for D. So 6 units left. So 1, 2, 3, 4, 5, 6, and then 2 units down, 1, 2. So there's D prime. And then C, of course, would go here. All right. So again, the exact same image. Notice, same size, same shape. If you end up with something different, you've done it wrong. All right, let's try another one. These aren't so bad. Now notice, this go around, it gave us the coordinate notation. All right, so let's see if we can remember what that is. So the coordinate notation in this case is subtracting 2 from x. So that means I want to go to the left. So I'm going to go left 1, 2. Now notice the y. Y hasn't been added to, y hasn't been subtracted from. It's the original y. So I'm not going to move up and I'm not going to move down. I'm just going to stay wherever I end up. So if I go 2 units to the left, 1, 2, I'm going to stop right there, and that's S prime. All right, let's do the same thing for R. We're going to go 1, 2 to the left, make our point, and that is R prime. Try it for T. 1, 2 to the left, make our point, and there is T prime. All we got to do is play connect the dots, so give me but a moment. And there it is. Same size, same shape. We know we're doing it correctly. All right, let's try one more. Notice this time our x is the same. X and x. We didn't add, we didn't subtract. So I'm not going to go left and I'm not going to go right. I'm just going to stay right where I'm at. but it does tell me I need to go 4 up. Notice we're adding y to 4, so that's an upward motion. If it was subtract 4, then we'd go down. So in this case, from x, I'm going to go up 1, 2, 3, 4. And there is x prime. From y, 1, 2, 3, 4. There's y prime. All right, from z, up 1, 2, 3, 4. Cool. Z prime. And then for w, 1, 2, 3, 4. There is w prime. And we'll play connect the dots. And it's okay if shapes end up overlapping. That's not a big deal. We really don't care about that. All right, if they overlap a little bit, no harm, no foul. All right. Now, this last thing we're going to do, and I know I'm watching my clock here. I'm a little bit over my typical 15-minute video, and that's okay. We'll be fine. Take a look. We're going to find the coordinates of the vertices for each figure after the given transformation. In other words, we don't have to draw anything. What we're going to do instead is we're going to make a list. All right, so let's do that real quick. F, G, H is what we got. So F, G, H. And what I'm going to do is I'm going to write down the original coordinates. All right, so let's make that list quick. So F is at -4. Notice I went 4 to the left. And then up 4. All right, I'm going to write that down. G is -2. I went left 2. And then up 5, so that's positive. And then H is at -1, 0. All right, so those are my original, I'm going to write this down, pre-image coordinates. Okay? Now what I need to do is the directions say I need to list all of the vertices after the given transformation. So what I need then are image coordinates. In other words, where would my new triangle end up? So I need to know where F prime, G prime, and H prime are all going to end up. All right, so this is an algebraic issue. So let's look. 6 units to the right means I add 6 to all of my x coordinates. So let's do that. So -4 plus 6, remember going to right is adding. So -4 add 6 is 2. -2 add 6 is 4. -1 add 6 is 5. Cool, so there's all the x coordinates. 2 down, that's a y issue. Up and down belongs to y. So if I'm going down, that's a subtraction. So I'm going to take this 4, subtract 2, and get 2. 5, subtract 2, that's 3. 0, subtract 2, that's -2. So these are the new coordinates for where this will end up. Now, you don't need to graph it, but I'm going to graph it for you real quick just to show you that these will make a new version of that just simply in a new location. So F prime is at 2, 2. So over 2, up 2. So there's F. Oh, better label it. F prime. G is at 4, 3. So there's G prime. H is at 5, -2. So there's H prime. Let me get all of my lines drawn in. So notice, same size, same shape, just a new location. And in this case, finding that location was pretty easy. I just either added or subtracted as needed. So finding the coordinates is actually a little bit faster than drawing. You're not spending all your time making those crazy little dots and trying to draw nice straight lines. So let's do it again. Let's try number 10 this time. Again, let's make our list. So H, let's see, J, K, L, there we go. And let's get our coordinates in. Oop, gonna go onto the grid here, and that's okay. J is at -4, 0. K is at -1, 4. L is at 1, 0. All right. Let's make our new image coordinates, and we'll see where we end up. So we've got J prime, K prime, L prime. All right. Let's try J first. It says we're going to go 2 to the right. So if I'm going to the right, that's adding. So -4 plus 2 is -2. All right. -1 plus 2 is 1. 1 plus 2 is 3. Cool. There's all my x's taken care of. All right. Let's try y's. We're going to go 5 units down. So that's subtraction. So 0 subtract 5 is -5. 4 subtract 5 is -1. 0 subtract 5 is negative 5. So there are my new coordinates. Notice we don't have to graph them. If we did, we would get a new triangle just like this. Now, if you're ever unsure about your coordinates, you could, of course, graph them and double check yourself. But in this case, we're good to go. All right, let's try these next two. These are nice because notice it's already in coordinate notation, so I don't have to know if I'm adding or subtracting. It goes ahead and tells me. So let's go ahead and get our list of the original coordinates, and then we'll draw our new list for the final image. So we have R, S, and Q. R is at 2, 3. S is at 4, 0. Q is at 3, 0. There we go. All right, let's get our new coordinates drawn out. So this will be R prime, S prime, Q prime. Now notice, in this case, with coordinate notation as opposed to the words, I don't have to figure out if I'm adding or subtracting. The coordinate notation tells me straight off. So to all my x's, I'm going to take 7 away. Well, let's go over here. So 2 subtract 7 is negative 5. 4 subtract 7 is negative 3. 3 subtract 7 is negative 4. So this is actually going a lot easier with coordinate notation. All right, let's try y's. Y's, it's telling me it's going up 1, so we just got to add. So 3 plus 1 is 4. 0 plus 1 is 1. 0 plus 1, of course, another 1. Simple as it can be. All right, let's do this last one then, and we'll call it a day. And hopefully our other videos aren't quite this long. But again, we had to cover a little bit of that coordinate notation stuff, or our coordinate plane stuff, rather. So let's see. We've got T, U, we got V, and then W. Awesome. Let's get it in. T is at negative 2, 1. U is at negative 2, 3. V looks like it's at 2, 2. W looks like it's at 3, 1. All right, well, let's get all of our new coordinates on there. T, U, V, W, and let's get those primes going. There we go. So to x's, we add 1. So negative 1 plus 1 is negative 1. Negative 2 plus 1, negative 1. 2 plus 1 is 3. 3 plus 1, of course, is 4. So notice how much faster that is. We don't have to take much time at all. Let's add our y's. In this case, we're adding 2. 1 and 2 is 3. 3 and 2 is 5. 2 and 2 is 4. 1 and 2 is 3. And there we are. We know our new coordinates. We didn't have to count anything out. We didn't have to draw anything. Coordinate notation works really well. So if you've got any questions or concerns, bring them to class. We'll do a few more examples from your worksheet that you should have picked up or printed out, and then we'll set you loose and you can do what you need to do today. Have a good day, guys.